Hey everyone, welcome back to another episode of Unscripted Coding. Today we are returning to our multi-part series, I suppose. We've been working week after week to try and figure out what is the best way to create some basic animations for stats. Now, we looked at Chart.js, and also I'm aware probably the easiest way is something like Excel or something very much geared towards charts. But I can't get over how awesome some of these look when you have really customized animations. So just revisiting and scrolling back, the inspiration for this was watching this video from Fallen.io. It is a visualization of the number of people that have died in World War II, and it's an amazing documentary. Please do watch it. I think it's only like 10 or 12 minutes long, so it's very short, very impactful. But what I love about it is how these stats, how these numbers are presented. So, for example, over here, you count up the number of people, um, and it's split up. Let me see if there's a better way of doing this. Over here, yeah, that kind of an animation here. The number is split up, and then it joins together, so there's kind of a smooth flow of where things go. Now, okay, so I'm scaling this down very simply because I know this is not done programmatically. This obviously isn't done on Excel, but probably somebody animated it all the way through. But we're gonna try and create something very small in processing. Now, the reason we're doing this in processing is because we tried Chart.js. That was okay, and that might get some of the visual effects I might want. We also tried D3, which really didn't pan out. So I want to go back to processing. Processing seems to be a bit of work, but I think we can do it. And if I start setting this up and setting the code up properly, I think I can reuse it and build it over time as something that I can use for other projects as I go. So I'll stop talking and start working on this. My first thought is we're gonna need some sort of function to build blocks and keep track of those blocks. And each of those will have a position, and we're going to move that position accordingly. And so that will be an interesting way of doing it. Yeah. So I think I'm going to have some sort of class where it keeps track of course, the dimensions, the color, those kind of basic things, but the position, the current position, where it wants to go, the speed it's moving. And we're just gonna spawn, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and spawn it accordingly, and then move based on the position. I don't actually think that's too bad now that I think about it. So we'll start working. Hey everyone. So let's see where we've got. Let me zoom in a little here, and you can take a look at what we've done. So I'm gonna play this out. What's gonna happen is the blocks are gonna add one at a time, and then after a certain set of time, it's gonna split up. Now I have done a 10-10, meaning everything shifts. It shifts both down and to the right. But if I change the X, it should just shift down. I think what we should be doing is doing 16. So let's try this again. Okay. What if I did this? There. I think this check. Oh, okay. I see. I will just leave this alone for now. And we'll walk through and we'll see why it makes that difference. But what have I done? What I've done is create a class, as I said, of a block. And this block will have a height and width. And this is to anticipate if we do, say, rectangles. But what's really great about P5 is you can actually use images. So you can use an image as a constructor, or you can create polygons. But the idea here is you can put little people figurines or anything else for that matter if you'd like. So if you want a little duck or a whale or some other animal, you can replace that. But for now, the square is fine. So we have a height and a width. You can put some other kind of classes or other constructors here to help with your figure. But for now, we're doing squares and we have a height and a width. The first thing we have is a position. So the x and y coordinates. So if it's 10, 10, it's 10 to the right, 10 downwards, and you get this square right here. Dx and dy are my destinations. For now, because when you construct it, it stays static. It's the same as position. But the idea is if I want to move it down, if I want to move it down, say, down 10, I might change the y to position minus 10. So nice and simple. You have a current coordinate, you have a future coordinate. Next bit is we have the setup. So if you remember from our first video with processing, how this works is very much like an Arduino. You have a setup function that runs once at the start. So for example, it creates the canvas. This is this gray piece here. And you run a couple initializing functions. The next piece is this draw function, which runs over and over and over and over and over. And the idea is you have to keep creating the square every single millisecond that it runs to keep it on screen. And the idea is if you want a square that moves across the screen, you will draw it at position 0, then position 1, then position 2, 3, 4, 5, 6, and so on, and have it move across the screen. So it just reruns. It clears a canvas, runs, clears a canvas, runs, and that's how it works. So for us, what we did was we set a couple global variables right here. We have a list of blocks. This is just an array of all of the elements we're going to be repeatedly drawing on the screen. Right now, I have show block at 0. This is the current block that's being added. So when you go through, we're saying add 0, add 1, add 2, add 3. And so we're going to increment this to ensure that the computer knows which one to be drawing. We have shift 1, false. And I imagine there's multiple shifts. So this shift is the one that moves it down. And the idea is I might have another shift later on up here. Currently, it's false. But when it switches to true, it means that it's done and we don't have to keep accounting for it afterwards. Move speed is just how quickly that shifts down. Frankly, now that I see it a couple of times, I don't like how it shifted down. I wish it was slower than that. But we can worry about that afterwards. And then we have the two initializing functions. One is necessary in processing. It's to create the back canvas. You might select a different color. You might have a background image, something to work with. But for now, it's just a gray 800 by 800 box. Finally, we have this function, initialize blocks, which is a function that I created down here. We'll just jump right into it. Initialize blocks, I'm going to have a number of blocks, and if you imagine Fallen.io, all of these are different. This might, I have no clue how many this is, but let's say this is 420. This one's a little less, 410. And the idea here is you want to make sure I'm able to build this over multiple places. So for now, we have a variable for number of blocks and the width of it. So this one looks like maybe 18, 20 different people. We just have a width of 5. Very simply, I'm creating these block elements and assigning them the right position. So block 1 will be 10, 10, so 10 to the left, 10 down bottom. And then the next one will have to be 20, 25 to the left, 10 to the bottom, 40 to the left, 10 downwards. And I'm just creating all the blocks with all of the initial positions correctly first. And this is where that math comes in. We're using division, floor, gosh, I can't remember, modulo, to get the right numbers. I struggled with this, actually. I remember my favorite online Coursera course was building video games with Python. We did this a ton to move things around, asteroids and cards and so on. I haven't done it as much lately, and so it kind of, you gotta stop and think for a moment. Which one do I need? Why do I need it? So for example, position X, you want to find out which block number you're at. So block 5, and you want to know how many it spills over, because when it's 1 to 5, you're lined up, but when it's 6, 7, 8, 9, you gotta reset back, and that's where the modulo comes from. Then you just multiply and offset it by an amount. Similarly here, it's you figure out which row you're in, and then you got a fixed position Y. We push it out to this list of blocks, and that's all we do for the initialization. Next bit. Oh, cool. Nope, didn't want that. Yeah, that looks cooler. Every time we draw, we're going to start a background. We're going to set the background color. So 0, we can do something pretty trippy as well. So you can change a background color through some math if you want, but let's go with black. Let's go with some really dark gray instead. Okay, this is where the magic happens. I was looking over and over whether there's some sort of delay function, which doesn't really make sense in a draw function. So in some code, you might run it top to bottom, and so you can put in a delay and say, before you run the next line, wait 2 seconds. Since this draw runs over and over and over, it didn't make much sense to have a delay function. Where it does what makes more sense is you're keeping track of time. So I kept looking for timing or some sort of how long has it been since it started. It turns out the function that you're looking for in processing is Framecount. It's how many frames have passed since you started. how many times a draw function has been run. So it'll be 0, 1, 2, 3, 4, like very, very quickly. And it should be 60 frames a second. So 60 means 1 second. So you can get, into the millions, billions, and so on, and you keep running it, but that's a good way to keep track. If you want something to happen every 60 seconds, you have a frame count modulo 60, then run this thing. It'll run once every second, basically. In our case, we just wanted just a slight delay so that we get 1, 2, 3, 4, one block at a time showing up. It didn't need to wait a whole second every single time. And so remember the show block, we're increasing it by 1. We're showing 1 additional block. And we'll skip this for now, but we're saying we can show an additional block every time frame count increases enough, and you can slow the speed down by a lot. So if I run this, you'll see that it goes a lot slower, but with a lower number, the boxes spawn much quicker. I'm going to skip this for now because I think it makes more sense to go here. This is where we actually start drawing the boxes. Ultimately, we want to create a square with the right position, with the right parameters. But what we're doing here is we're going to go through every single one of these blocks and create a square for it. What we do also is we want to show it just up to the point of show blocks. So if at that point we are only showing block 2, we don't want 3, 4, 5, 6 to show up. So we're just scrapping it. That's where this comes in. And so we get to a number of blocks, we create a square, it appears on the screen. Now, that will get you to the first bit right here, stops here. The next part is the shifting down. That's the part that I thought would be a little more difficult. Get rid of this, make this code shorter. What we've done, and this is purely personal choice and laziness, you got to figure out a point in time when you want to make that shift. And so for me, I use that same frame count. I just latched right onto it to say once we've shown enough blocks, and it keeps counting up, once we decide to show twice the amount of blocks we need, then we're going to initiate that shift block function. So when show block divided by 2 is greater than the block's length, so it's twice as large, and we haven't already moved it down. Remember, this will keep running, and if I don't have some sort of flag, it'll just keep shifting them down, basically go straight down the screen on the left. I think you've seen that in the video already. The idea is we only want to run it once, so we have to switch this flag to true. And then we finally run the shift blocks function, which we've written down here. Very simply, we are finding a sub number of blocks. Over here, it is the bottom, I think I said 23 blocks, and we want to find a vector. How far down do we want to move it? Over here, we want 23 blocks, and we want to move them 10 to the right, 10 to the bottom. And so for that, we're just going through every single block in our blocks array and adding the right vector. So remember when we started, we had the current position and the destination position. We keep the current position the same, but we shift the destination position. We add to it. Okay, that will set up the function, but that doesn't actually draw. So what happens here is this last little bit. And this function says, if your current position and your destination position is not the same, then we're going to adjust the move speed. We're going to adjust your current position to move closer to the destination. And over here, I set a move speed, so it moves 2 at a time. You can make it go faster or slower if you want. We did 1. It would move a little bit slower. Yeah, that actually looks better, I think. And so we're going to draw it a number of times. I think there would be 10 steps because we're going to move 10 down and 10 to the left. And yeah, so we keep adjusting the current position, and every frame it's going to move one and another one and another one until they match up. And then once they're matched up, their current position and destination position matches up perfectly. Where I said I had a problem here is if I did 0, you'll see it just move right down the screen. Like so. Slower than before. But the reason is because I'm checking both of them at once. And I am adjusting both of them at once. The assumption here is that the destination is always the same. So I'll have to fix that up. It's just a couple more if statements to make it work. But very simply, we have something that works, that we can replicate. This is all in code, so I can create a couple different one of these, reuse the functions, and create one for United States and Germany and UK, and set different colors as well. So that worked out better than I thought. I'm going to save this afterwards, so I hope I don't lose it, but let's scroll down so you can see the text. I hope you found that helpful. I know I meandered a bit because we tried different packages, different solutions, but I hope in the last couple of weeks, and if you were following the videos, you kind of see the process. You don't latch on to the first library that you enjoy. You play around with it. You don't have to spend a lot of time, get a sense of it, and see if it's a right tool. Ironically, processing was the first one that I checked, but it rarely is. You want to try a bunch of different tools to figure out which one fits your use and your needs best, and try a couple different ones before you really sink your teeth into a problem. So turns out processing was the best, but if you needed something easier, something more aligned to data or documents, this probably isn't it. If you enjoyed this video, do give me a thumbs up, do comment and subscribe. If not, do comment as well. I'd love to hear from you guys. I hope you enjoyed this video, and we'll see you next week. Thanks.